Guys, welcome back to Tronics Energy. Now I want to start a new series where we are going to try and simulate one of the various motor starters that we have out there on my breadboard. We are going to use my DC motor as the output. So we are going to try and see if we can understand various types of the motor starters, how the logic operates in the real world application, and try to relate how each component resembles the other one in real world AC motor starting circuits. Now, today we're going to start on the simplest one of them all, which is a DOL. Now, the DOL is the simplest motor starter that we have. Basically, you press start to start the motor, and you press stop to stop it. That's the basic way. That's the basic circuit or the basic starter method to run a motor. Now, in an AC circuit, a DOL usually has some very few components. We have MCB, which is a miniature circuit breaker. It's kind of a protection which checks if the circuit has a fault or a short, then it trips. To resemble this in our circuit, we have a fuse here, which is coming from the power supply, a fuse then to the control circuit. Next, we have an overload relay, which checks if the motor is drawing too much current as it's rated, or larger than it's rated. Then if the current is too much, then it becomes open and the rest of the circuit cannot operate. Now, to resemble this in our circuit here, we have a comparator circuit here, which checks the amount of current the motor is drawing from the V reference that we have set. Now, if this motor is drawing too much current than the V reference, then the trip circuit is going to be on and it's going to disable the rest part of the circuit. Next, we have a stop push button, which is this one, stop push button. Next, we have a start push button, which is this one, start, then stop. Next, we have an hold on connection. Now, the hold on connection in an AC circuit is just a wire which is connected from this point 3, the 3 output. This connection, these numbers are usually on the devices, the NC and the NO push buttons. So you connect it from here, you can connect it from here all the way to this point of the NO contactor. Now from that point, it becomes a hold on. Now you don't need to just keep on pressing the button for the motor to continue running. The motor itself will have the contactor itself will have power connected to it via this connection to the coil. Now, rather than it passing through here, it's going to pass through here, going to the coil, meaning that it's going to remain on. Now, from there, we have now that hold on, to represent it here, or to resemble it here, we have this NE555 in bistable mode. Now, an NE555 in bistable mode has two stable state, on and off. Now we press on to make sure it remains on, and that flip-flop inside cannot change its value until you press the reset. Now these are kind of a reset, but in an AC circuit we are going to, it's a stop push button. So we press that set and we reset to stop the motor. Now from there we have the MOSFET, which usually we are using it to control or to drive this motor using current only. Use a very minimum amount of current to drive the motor, because the motor drives usually draws a lot of current. So to make sure we don't sag, we don't sag the supply, we just pass it through the MOSFET to make sure that it drives well. So that's the basic type of motor starter that we have. It's a DOL kind of a starter, and yeah, so this is what I wanted to show you guys today. Next time we are going to check on a forward reverse kind of a connection, in which we are going to press forward, then we are going to press reverse to run the motor in the opposite direction. So yeah, this is what I wanted to show you guys today. Thank you very much, guys, for your time, and if you have any questions, you can just ask, and hope to see you next time. Goodbye.